The urge for exploration, the search for meaning and truth, has let humanity advance further than any other species on this planet. Nowadays, it is split into many different disciplines and subjects. But that was not always the case. In this video, we will explore how and when science actually started and how it evolved to be humankind's greatest tool. The traditions out of which science arose reach way further than recorded history. In prehistoric times, oral tradition was the way humanity advanced, which means that techniques and knowledge were passed from generation to generation through speech. Later, around 3400 BC, the cities of Sumer in Mesopotamia, trade and administration reached a point of complexity where memory only wasn't enough to transfer knowledge, since it was vital to record transactions in a permanent and unalterable form. Writing was invented. Its development enabled humans to store and pass on knowledge with greater accuracy than ever before, and it was the basic prerequisite for the development of philosophy and the science of ancient times. In Mesopotamia, early stages of medicine, astronomy, and mathematics came into being. Likewise, in ancient Egypt, there were developments such as a decimal numbering system, geometry, recipes for diseases, and also a calendar which contained 12 months, 30 days each, and 5 days at the end of the year. Since lunar cycles weren't considered, the Egyptian calendar was much simpler than the Babylonian one used in ancient Mesopotamia. Now we'll venture thousands of years into the future, to approximately 600 BC, where Thales of Miletus, a Greek mathematician, astronomer, and physicist, predicted a solar eclipse, at least according to Greek historians. Whether or not this was true, the solar eclipse actually ended the Battle of Hales, and with that, a 15-year-long war between two rivaling factions. The approach of the ancient Greeks deviated from the one of earlier civilizations. They wanted to explain the world without God. Even though philosophy and science weren't separated, the minds and discoveries of this era wouldn't be challenged for over centuries after the downfall. After finding seashells on a mountain, Xenophanes concluded that the entire world must have been underwater before. 50 years later, Democritus proposes that everything is made out of tiny particles called atoms, or atomos, which means impartible in Greek. In 250 BC, Aristarchus of Samos suggests a heliocentric world model, where the Earth isn't the center of the universe. Meanwhile, Eratosthenes accurately measured the circumference of the Earth, only with sticks, his feet, the shadow of the sun, and a brilliant mind. Hipparchus discovers the precession of Earth's orbit and creates the first star catalogue in 130 BC. Also, many advancements in medicine, zoology, engineering, and mathematics were made. For instance, Hippocrates outlined many conditions and diseases. Theophrastus founded the discipline of botany, and Hero invented the steam engine. And that over 1,000 years before it would be seen again. In the East, specifically China, there was also a lot of scientific progress throughout the centuries, like the invention of paper in 200 AD, gunpowder around 100 years later, the first compass, and an interest for the observation of interstellar objects. One of the most important Chinese scientists was Zhang Heng, who lived during the Han Dynasty. He was educated in a vast variety of different fields and, for example, invented the first seismograph. Nevertheless, the progress was hindered, most likely due to predominating philosophical and religious ideas, mainly Taoism, which had influence on Chinese intellectuals. Another country located in Asia is India. Here, particularly mathematics and astronomy were the prevailing disciplines. The sine function was developed by Aryabhata in the year 499. Furthermore, mathematician and astronomer Brahmagupta explained the use of the number 0. The Indian numeral system would later be used and improved by the Arabs. While Europe was stuck in the Middle Ages, science in the Middle East flourished. This was the Islamic Golden Age. In the 8th century, the capital of the empire was moved from Damascus to Baghdad. There, a huge library called the House of Wisdom, comparable to the Library of Alexandria, emerged. Books from all over the Greek city-states and India were collected and translated. Many of the discoveries of ancient Greece and India would be built on, like Hipparchus' star catalogue and mathematical work from Greek and Indian mathematicians. For instance, the numerals 0 to 9, which we use nowadays, are Arabic numerals, originating in India and being refined by Muslim mathematicians. And have you ever wondered how the stars in the night sky got their names? Well, many of them have Arabic names or names that derive from Arabic. As Neil deGrasse Tyson explains, Betelgeuse is the star's common name, Arabic for armpit of the Great One. Actually, 2/3 of all stars in the night sky with names have Arabic names, an homage to their stellar navigational skills 1,000 years ago during the Golden Age of Islam. And indeed, astronomy was incredibly useful for Arab nomads traveling through the desert. Additionally, the Golden Age of Islam gave birth to the world's first experimental scientist, Abu Ali al-Hasan ibn al-Haytham, or simply al-Hasan, whose work on optics would later be picked up by none other than Isaac Newton. He was the first to actually make hypotheses and test them through experiments afterwards. Eventually, knowledge from the Middle East would reach Europe, starting the scientific revolution. Here in 1620, Francis Bacon, being influenced by Al-Hasan, would declare and outline the scientific method that is, in essence, in use today. Of course, many other ideas were shared and discoveries were made, but it is simply out of the scope of this video to mention and explain all of them. To name a few, in astronomy, Nicolaus Copernicus proposed a heliocentric world model, just like Aristarchus before. In biology, the first single-celled organisms are detected, opening up a whole new world. And in physics, Newton and Huygens would debate over the nature of light. Over the next centuries, the different scientific fields specialized more and more, and new ones would emerge as well. In the 18th century, huge advancements in chemistry would be made, and the periodic table developed. Later, electricity and magnetism would be discovered, and the idea of intelligent design by a divine creator, challenged by Charles Darwin and his theory of evolution. Humanity would, with time, gravitate more and more towards questions of existence in space-time itself, with Albert Einstein's theories of general and special relativity, and later quantum mechanics. In the last decades, we've had such fast-growing technological advances that machines might very well pave the way for theories that we would have never even thought of before. While technology and science both have moved forward in rates never seen before, there is one thing that is still unchanged and welded into our human DNA. And that is the curiosity, the urge for discovery, the impulse to overcome the next mountain and look what lies behind. Thank you so much for watching. I hope you enjoyed it. This was actually my very first video, so feel free to leave suggestions and feedback in the comments. And hopefully see you next week. Bye.